All right. Well, a few days ago with procedural terrain, I had airplanes flying over an endless terrain, and they were being chased by uh, homing missiles, if you want to call them that. Uh, they were uh, rockets that had followed a target. So the idea for the homing missile came from something I got from the asset store. It's a weapon system packed by Daniel Cole. Uh, there's the link to it. Um, and basically, what I'm going to show you here is the physics behind uh, Dan's rockets. He of course has models for the rockets and gun turrets and other stuff that is beyond what we'll do here. This is his game. Um, so one of the things I liked about his rockets were that they accelerated gradually, so they have some thrust that ramps up over some amount of time. So they don't instantaneously leap to some velocity. They kind of take off like a real rocket might. And there's actually a ramp for their turning as well. They also don't immediately home in on their target. They fly for a little while to kind of get stabilized, and then they select their target. These are basically time accumulators that ramp up, and when a certain time has elapsed, they change their own settings. What I thought was really clever about it was the way he handled the physics of the rocket. And he did this with a kind of two-part solution. Um, he separated the thrust direction that accelerates the rocket from the rocket orientation. Now, we think of rockets as firing stuff out the back, and that's being the primary thrust, but rockets, of course, have little fins that deflect that thrust in different directions, and that's how they steer. And he did this by having an invisible object with a rigid body with a collider uh, that is the parent on which the rocket motor script resides. And then as a child object of that, there's the visible representation of the rocket. The invisible collider is oriented so that its forward direction coincides with the steering force direction. So we're going to be applying forces not along the axis of the rocket, but at some angle to it. And that's what steers the rocket towards its target. The visible rocket object is oriented to point along that invisible rigid body's velocity vector. So the rocket will align itself with the direction, the velocity that it's moving. Velocity and acceleration are not the same. And of course, since this is all physics and we're applying forces, everything gets done in the fixed update. So a couple of various bailouts. If the rocket hasn't been launched yet, we return the target acquisition timer, the ramp for the current thrust and the current turn rate. These are all just time accumulators, and uh, the, the thrust and turn rate ramp up to their maximum values. Here's where the bulk of things resides. If it has a target, it computes a line of sight vector to the target. If it doesn't have a target, of course, it just flies straight ahead. So that's before it's acquired a target. And then this part down here is where a lot of the physics goes on. You see the project function here. This is projecting d-loss, which is the change of line of sight onto the line of sight vector. And vector3.project takes a vector and projects it onto a second vector. And the way to think about this is that our vector has some point along this line that is as close to this point as possible. These points are all further away. These points are all further away. This point is the closest. So this is kind of the length of this vector in this on normal direction. The gist of this physics, we have some previous line of sight, and because of the rocket's motion, its line of sight has now changed to this direction. These are vectors. So d loss, change of line of sight, is this vector, the green vector here. And so I'm taking d loss and subtracting from it the projection of d loss onto the line of sight. So if I slide the green vector down here and project it onto the line of sight, I get this red vector. And then I'm going to subtract it, so that's the negative. And so this is giving me this magenta vector here that is my acceleration. That's pretty cool. We have a component of acceleration along the line of sight, so that's pushing the rocket forward. We have a component in this magenta direction that is turning it in a way that will presumably predict where it's supposed to go. This is where it used to see the object. Here's where it now sees the object. So it's going to be turning this way to ultimately get to it. And there's also a component of its previous acceleration. So this is kind of a relaxation. This NC is a tuning parameter that kind of controls the tuning rate, controls the strength of the steering, how rapidly our rocket responds. So if I have a target that is got target and target are not null, compute a rotation that points in the up direction, that's perpendicular to forward. So we're kind of going to roll our rocket so that its up vector is in the direction that my acceleration is applied. And I'm going to rotate towards that rotation so that the invisible collider is turning towards the direction that it wants to accelerate. These are all mediated here with a rotate towards. So there's our rotation, target rotation, and we're going to rotate towards that, rotate the transform rotation towards that target rotation with a time delta time times the current turning rate. So this is how rapidly the object's going to turn towards the object. And then once we get this thing oriented, we do an add force on the rigid body in the forward direction. We now have our object pointed, our invisible object pointed in the direction that we want to apply the force. So we just apply it in the forward direction. And at the same time, we reorient the mesh transform, the visible rocket, to be aligned with the velocity vector. So if we have a mesh transform, the thing that we see, we form a rotation that points it in the rigid body's velocity direction. So all very simple. Here's kind of a picture of what this looks like. There's the visible rocket. Here's the invisible collider that is orienting itself so that its acceleration vector is along the blue. And here's some examples of the different vectors as a rocket flies out here. I can show you this in the game. Whoops, wrong one, sorry. I can show you this in the game. I gotta maybe make sure the gizmos are on so that we can see the lines. So I have a little, this is a top-down view. There's the rocket. The white vector is the forward vector. The blue is the line of sight. And the red is the acceleration, and the green is that little D-loss. I can fire a rocket manually here, and I can steer this target around so that you can see all these vectors changing as the little rocket tries to steer itself to hit that target. And this is worth playing around with a little bit just to see things go on here. So, and of course, there's a finite lifetime at which point it blows itself up. Now, way back in the fixed update, we had a bailout that if the rocket was not launched, we would skip the update. And we also have a public function fire that takes the launcher and the target sets now rocket launch to be true. So this is now going to go back and do the fixed update. And basically all I'm doing here is assigning a target to my rocket, making sure that I don't collide with the launcher. In Dan Cole's case, he had a fairly complicated launcher. The launcher script also has the potential for an array of rockets that we can choose from. We can also have an array of targets that we can choose from with various parameters for lifetime, rotation range, thrust, and so forth. In start, we find all the game objects with tag target, catching copies of their transforms. We have an auto launch Boolean that starts a coroutine that will launch a rocket periodically. And we also have a manual rocket. So if the auto launch is true, this coroutine starter fires rockets of different types selected randomly at randomly selected targets with this ignite rocket function, and then it waits a certain amount of time. The find target selects targets from an array. It does allow for the possibility that targets may have been destroyed, so it does test to make sure that they're there before it actually fires them. And here's a manual launching where we ignite rocket manually here. Ignite rocket is the one that actually calls the that instantiates the rockets. So it has the rocket that it's going to instantiate, or the rocket number, and the target number that it's going to target. It makes the rocket, gives it a name, assigns some random rotation to it so that they don't all go off in the same direction, gets the motor on the rocket and its collider, and as long as it has a motor, it sets its parent to be null, so it's no longer the child of the launcher, sets lifetime thrust, enables it, and fires it. So that's all there is to it. Now, of course, I get carried away with any of these things, so I have that, I have an animated target. No, that's not the one. I want the controlled target that I can drive around here. So this is on auto fire, so it's firing rockets all the time that are chasing this little object. If I don't keep it moving, it pretty rapidly gets hit and eventually disappears. A nice kind of accidental feature you might not have noticed there, but when the target disappeared, all of the launched rockets kind of went limp and crashed into the ground. Here's a car situation where the rockets are targeting my car, and you really get rained on here. Um, with the different planes here, and I'm going to go to a kind of short one. This is a waypoint plane that's flying a circuit. Um, it so it's not doing anything evasive. The rockets are all being fired out of that central spot there, and eventually it's going to get hit by something. So then there's some hits, and I spent a lot of time doing the crash animation here. And it, of course, recycles back to the start again. There are a couple of dogfights. So you can have a dogfight with a waypoint AI or with an AI that is targeting you, so it's following you pretty scrupulously. It's really hard to avoid. And here's one that's two airplanes. One is a waypoint plane that's flying a circuit, and the other is a dogfight plane that's following it and targeting it. They're both on autoplay. One thing to remember whenever you fire a missile manually, which is the space key, is that the AIs fire too. So the more you shoot at it, the more it shoots back at you. So be aware that if you flood out a lot of rockets into the world, they're after you as well. This will be available for your amusement. Uh, uh, and I think I'm going to end sharing at this point, and I'll stop the recording, and I'll see you all in class. Bye.